Hey, it's been a while, so let's get right into it. I wanted to add tests to this SQL generator, and as you can see, it may probably build some SQL, generates SQL for insert, update, delete, and select queries. Uh, what I wanted to do is to cover this class with some tests. And as you can notice here, there's a pretty ugly, well, I don't know, I don't like them very much, dependency to a static class. And the problem with static classes is that they make normally your tests difficult to build, to make. So at first, I wanted to get rid of this dependency. And how do you break such a dependency? Well, let's do it here. You can normally use the pattern subclass to test, and in this pattern you simply put this into a method. Oh, what? Okay. Dependency. Let's call it protected virtual what is it? Entity mapping the entity dependency. What is this madness, you would say? Turn. So this should dependency. There's an M missing here. Okay, this should behave as before. The only difference is now we have encapsulated this call into a method, a protected virtual method, so we can overwrite it in a child class, as I did it here. What is SQL generator for tests? SQL generator for test is a simple class that overrides the entity mapping. Oh, here, what? Like here. No, what is this? Oh, yeah, of course. Updated. Here you have. I called it update entity mapping. So it overrides update entity mappings into nothing. So when the constructor of the class passes through here, it doesn't do anything. Okay, that's it. That's how you break a dependency. Now you have a class that doesn't depend on an internal implementation of an entity mapping entity. Then what I did? Well, I started building some tests, and suddenly it became actually difficult to build a stub for entity mapping. Let's see the stub. The stub is a pretty big class with a lot of properties that I had to tweak to make the test work. And in the end, you see that my test works. Hey, it passes. Sadly, the query isn't correct. It doesn't build a correct query. Here we have something missing. So, after a while, I understood that this path would lead me to some pretty difficult test to build, and I didn't want to build just the unit test. I wanted to cover the tests that already exist. So why don't use the code that already exists, even though it's not actually unit test? Well, let's try it fast. Let's go to our SQL generator test and var_sut equals SQL generator. SQL generator needs here a class, for example, dummy. This class doesn't exist. Oh wait, new dummy. What are you doing? Create type dummy. Okay. So for example, we want to cover select. So sut.select, the simplest predicate that I can think of is true. The result. Okay. Now we have a result. We have to compare to something. Assert that result is equal to, let's see what happens. Okay, as expected, the test fails and it builds a query like this query, which turns out to be wrong. Well, why is it wrong? Let's look at the documentation in the Debonair repository, and we see that this, let me see, this customer is a class that represents some entity or a table, and we are giving the class an entity without anything. So actually this should at least throw an error, but let's say that it throws when it tries to run this query, no? So then what could we do to make this query, this test, to build a nice query? We can try to mimic this. For example, it's just an ID and a customer name, and let's see what happens. So we have this inside the select, and please give me something else. I don't want to step in the bug. Oh, it built something. Doesn't look quite right. Why is it giving me this? Because we aren't giving him any. Also, this should fail. You know, if I want to select anything, I suppose this should be select everything. Give me everything here. Oh, maybe I should. No. Okay. I think that this is a little bug. I will ask James about this. So, what do we do here? We have a customer name. We want to select something from the customer name. So, let's build. You can read more in the documentation, of course. For example, an ID equals and run again. It will fail, of course, but it will give me the correct query. And now if we run it again, it passes. Yay, magic. Ha! So it turns out that this piece of code builds query based on a class. And it turns out there are already tests for that one, and those are let's see here. Look how many tests. A lot. They are working, and they assert that this class works. Probably they choose the happy path, so I will add some tests that to me are failing. For example, if I don't specify anything here, this shouldn't work, and if my class is empty, this shouldn't work. But okay, those tests are already here, and I don't have to do anything, right? The key takeaway here is that you should always strive to find the simplest thing that could possibly work. I was trying to build test for just this unit of code, and great, I managed to separate and to break this dependency, and that is great because that enables test. But it turns out that the test following that path were really huge and could become unmanageable. So in this case, as I'm building characterization test, the simplest thing was to add test using the tools that already exist, and thus the dependency. This dependency is able to work pretty well with this technique, so why not use it to add the test? And when I realized this, I rediscovered that there are already tests for this. So here the simplest thing that could possibly work was added no test at all, apart from those that cover the wrong cases that I will add later. But okay, that's it. Pretty easy, no? Think a little, try to find how to simplify the things, and that's it. Bye.